Hello student, welcome to my lecture video again. In this particular lecture video, we will be talking about formulas, formula of a compound. We have already introduced previously that a compound is represented by a formula of that particular substance. As you have already explained, that a compound is formed by chemical combination of atoms of the different element. For example, suppose we are talking about a compound of between hydrogen and oxygen, two element. When they combine, they produce couple of compounds. We will be talking about two compounds, not couple. Actually, it produce only two compounds. One is called water, H2O, and one other is called H2O2. That is called hydrogen. This is water, and this is called hydrogen peroxide. So this is used for cleaning purposes in our daily life. So you look at it, this hydrogen and oxygen, two different elements, they produce two different compounds, and they are represented by two different formulas. Every individual compound has a unique formula. In this case, water is represented by H2O, hydrogen peroxide is represented by H2O. So is there a different kind of formulas? Yes. The formula as a whole, which is used to represent the compounds, can be classified in many ways. But in this particular chapter, we will be talking about the formula can be classified into mainly two, and a little bit we will be talking about structure. So formula can be classified in three ways to say: empirical, molecular, and structural. This one is mostly used in your higher classes when you will study organic chemistry, or organic chemistry, which you will study after you complete two general chemistry class. So our main focus will be empirical and molecular formulas, and we will talk briefly about organic compounds. Okay. So let's see what is empirical and molecular formula, and what is their differences. So empirical formula is relatively simple, and a molecular formula is the actual. What exactly empirical formula means? Sometimes we write empirical formula EF. It represents the simple ratio of atoms of element present in a compound. In a compound. So then how it is different from molecular compound, a molecular formula? Molecular formula is represented by MF, and it represents the actual number of the atoms. Actual number of atoms present in a compound. Okay? So suppose a compound between nitrogen and oxygen. We are talking about, and it produces a lot of compounds. Actually, nitrogen and oxygen, if you take these two elements, they produce probably 5, 6 different compounds, but I will be taking a specific compound called N2O4. If you look at this one, this compound N2O4, in one molecule of N2O4, there are 2 nitrogen and 4 oxygen atoms. So that is called exactly molecular formula. It represents the exact number of atoms present in that particular molecule, which is 2 atoms of nitrogen and 4 atoms of oxygen. But if we look at the number of nitrogen and oxygen atom, 2 and 4 has a common factor. What is that common factor? 2. So if you divide these two numbers, 2 and 4, by common factor 2, this one will be N2. And this is called empirical formula. Empirical formula represents the simple ratio of the atoms, nitrogen and oxygen. What is the ratio? 1:2. But in case of a molecular formula, simple ratio is not good enough. You have to represent the exact number of atoms present inside N2O4. So if a compound formula you see and you feel there is a common factor by which you can simplify it, definitely it is a molecular formula. But in case of a empirical formula, there will be no such common factor. So does it mean that every compound has a empirical formula or molecular formula? No. Sometimes you will find there is no way to simplify the number of ratio of the atoms. In that case, you will have no way to differentiate between empirical and molecular formula. For example, I am telling a compound C6H12O6. This is glucose. Look at it. It is made up of three atom type of atom, carbon, hydrogen and oxygen. The ratio is, if you take the number actually 6, 12 and 6, and you will find the ratio is 6. So if you divide by the 6 the number, it will be CH2O. Since there is a common factor, that is empirical form, and this is molecular form. Okay, but let's take for example CO2. This is carbon dioxide, and look at it. It has ratio of carbon and oxygen 1:2, and there is no common factor by which you can simplify the ratio of the atoms. So in this case, molecular formula, this is molecular formula and empirical formula are same. So in this case, really speaking, there is no difference between empirical and molecular formula. And some of the instructor or some of the scientists believe we should say that it doesn't have a empirical formula, it has only molecular formula. But nonetheless, we are referring to the same thing in this class. In my class, in this class, we will say empirical formula and molecular formula are same. So it is not necessary that every compound or the formula of every compound has a empirical and molecular. Sometimes they are same because there is no common factor. So now we will practice some of the things that to define which is empirical and molecular formula. And also there is one question, how do you find out empirical formula and molecular formula? And we will solve some problem that will help you. So before I jump on to solving numerical problem, I would like to say a little bit about structural formula. Although I said it will be discussed in detail in your organic chemistry class, but nonetheless it is necessary to give you a basic background of the structural formula. So if you look at structural formula, sometimes you will find two different compounds or two or more different compounds are represented by same formula. Okay, say let's for example, I am writing two formula. And we will count the number of atoms and write down the formula. So if you look at it, so let me erase this one. This one compound It is made up of carbon, hydrogen, and oxygen. And the second compound, I will write it down like this one. And if you count these two separate compounds, you will find and write down how many carbon, hydrogen, and oxygen are present here. You will find they will have 2 carbon and 6 hydrogen and 1 oxygen. Okay? Carbon 2, 6 hydro, 1, 2, 3, 4, 5, 6. So look at, they are exactly same formula, but they represent two different compounds. So sometimes the formula of a compound is not good enough to represent the uniqueness of the compound. They need to be written in terms of structure. They are called structural formula. So if you write these two compounds in this way, normally we write in many compounds in chemistry, that's not good enough. Actually, this is a compound called ether, and it is called alcohol. They are very different compounds, but represented by separate formula. That's called structural formula. So sometimes it is necessary to know how they represent, how they look. More discussion will come maybe in the end of this chapter or in your previous, say, next class or next to next class. Now, just let us try to find out more about empirical formula and molecular formula, and let's discuss with some of the problem we have. So look at it, and we are trying to find out that empirical formula of this particular compound. First thing, look at the way it has been represented. What is the empirical formula of this? So it means they indirectly told you this is a molecular formula. And also you can justify yourself. Why it is molecular formula? Look at it. In this compound, they have carbon, hydrogen, and oxygen, 3 elements, and their numbers are 4, 10, and 2. Is there a common factor? Yes. Can it be simplified? Yes. So if it is, so it is definitely a molecular formula. And if you want to make it a empirical formula, you will divide by the common factor 2. So it will be C2H5O. This is the empirical formula. So your answer is this one. So the conclusion is that if a molecular formula is given, you can find out, say, an empirical formula just by simplifying the ratio of the atoms in no time. And it is pretty easy. But move on to the next number, 60. So if you look at it, what is the possible molecular formula of this? First thing, are you agreeing to that this is a empirical formula? Why? Look at the ratio is 4:1. Is there a common factor that we can simplify? No. So it is an empirical formula. Also, as I said, sometimes empirical formula and molecular formula could be same. So if empirical formula is given, actually you cannot find out the molecular formula for sure. But definitely you can give some choices. So, it could be like this one. Same if the empirical formula or molecular formula is same, or like this one. The common factor is 2. Sorry, 3. So if you look at it, it has common factor 1, common factor 2, common factor 3. So if an empirical formula is given, you can only find out the molecular formula and give it some choices. And it could be a number of choices. So in order to look at from this particular chart, only this one is possible because it has a common factor 2. The number of carbon, hydrogen, and oxygen is increased by 2, so it will become C8H8O2. Why the other options are not? So if you look at it, it is 12, it is 12, it should have been 3. if it is a molecular formula. In this case, it is not possible. The ratio is 4 is to 4 is to 1. 2 to 1 is not anyway maintaining the same ratio. So these two are not possible. Your only option is A. So in these two problems, you will find if molecular formula is given, you can find out an empirical. If empirical formula is given, you cannot find out the molecular formula for sure, but you can come up with some choices. But now the question is that how could we really find out the empirical formula and molecular formula? And given a choice, which one will be easy or which one you will like to find out fast? The answer is empirical formula is easy to find out compared to molecular formula. So given a choice, you will always like to find out the empirical formula first, and then you will find out the molecular formula. From empirical formula, you will find out the molecular formula. So in this particular section, I will show you first how to find out empirical formula first and then go to molecular formula in a sense. So if in this ECA you will find you have 61, 62, these two problems, how to find out empirical formula, and then we will show you in 63 and 64 how molecular formula are found out from empirical formula. So I will do 62. It is little bit, I will say, a long and complex problem. So I will solve it and then you will go from there. Okay, so we will be showing you how to find out the empirical formula as per the question number 62. The very first thing you have to know, in order to find out the empirical formula, you cannot find out the empirical formula out of nothing. You need some experimental data. So in order to find out the empirical formula of the compound, you need what is called elemental composition of the element. What data you need? Called elemental composition. We have already discussed in previous slide, about the composition of an element in terms of percentage. Exactly that same data is needed. In this case, you will find out this compound has the 4 element: carbon, hydrogen, nitrogen, and oxygen, and all together they should be 100%. If you add all of them, you will see they are 100%. So this data is needed. So how much is individual element present in the compound? The question is that should it be always in percentage? Not necessarily. As long as the units are same, that will be fine. If it is percentage, that is also good. For example, here in this problem, it is 70.79%, hydrogen is 8.9%, 4.59% is nitrogen, and oxygen is 17.52. But if you go to 61 problem, the elemental composition is given in milligrams. Perfectly fine. It could be kilogram, it could be gram, as long as the units of the different elements present and their quantity is given same unit, that will be perfectly fine. So now, if this data is given to you, or you have to find out by doing experiment. Actually, in a little bit higher class, you can do some experiment to find those kind of data. So once you have that elemental composition in common units, you can find out the empirical formula. So what you have to find out? You have to find out the ratio of the atoms: carbon, ratio of hydrogen, then nitrogen, then oxygen. So what you will take the individual numbers and divide by their atomic weight. Carbon is divided by 12. Oxygen is divided by approximately 16, that will be fine. Hydrogen, it is 1, and then 15.72 divided by nitrogen, it is 14. So, no, sorry, this is oxygen. So it is oxygen, it will be sorry, this will be oxygen will be 16. Sorry, this one is hydrogen. This will be 1. Sorry. This one is nitrogen. So this one will be 40. So be careful. You divide by the appropriate atomic weight. This is carbon, so divided by 12. Second one is hydrogen, divided by 1. Third one, 4.95 is nitrogen, it is divided by 14 and 16. Then divide and find out the number. This is approximately 5.9. This will be same, 8.91. 4.59 by 14 is 0.327, and this one is 0.98. Then what you do, you look at all the numbers that you found out and see which one is the least number. So if you look at out of this 4, this is the least number, 0.327, which corresponds to the quantity of nitrogen. Then divide all of them by the same smallest number. Why? You will understand in a minute. So divide all of them by the least number of all the atoms we have. So if you find out, it will be approximately close to 18. This one will be approximately close to 27.2, and this one will be equal to almost, not it is exactly 1, and it will be somewhere 2.99. Then what you do? You round up to the nearest whole number. Suppose it is 18, then it will be 27, it will be 1, this will be 3. So actually, the empirical formula will be 18 carbon atom, hydrogen 27, oxygen, nitrogen 1, and O3. So this is your empirical formula. This is the way to find out. Now you understand why we divided by the lowest number, so that it will be coming to 1. So you have to quantify the number of atom which is present least to the least possible number, and that is equal to 1. So this is the way to do. Take the individual ratio or individual quantity in same unit, divide by their atomic weight of individual element, and divide whatever the fractions you get by the least possible number, and then find out whatever the number and round up to the nearest whole number. And that will give you the number of atoms, individual atom, and you can find out the empirical formula. Although I will ask you do the 61 on its own, but there is another possibility may happen. For example, in a sense, you will find this number, when you divide by all of this number, by the least number, one of them, this one, suppose comes to 1.59. So exactly, 1.5, sorry, 1.51, which will be, so should you round up to 2 because it is more than 1.5? No. If it is, the number is somewhere not close to a whole number, one of them is 1.5 or 1.333, it tells you something. You should not round up unless and until the individual numbers, like 27.2 is pretty close to 27. 2.99 is close to 3, but 1.59 is somewhere middle. 1.33 is not exactly close to 1. So in that case, it means you have to multiply all the number by 2. So it will be 3, and it will be 2, it will be 54, it will be 36. So whenever, by doing this technique, if we end up one number is not close to the nearest whole number, it means all the number has to be multiplied by a factor, maybe 2 or 3, to make that number a whole number instead of rounding up to the nearest whole number. Okay, so you do 61 on your own. It is pretty simple. Now we know how to find out the empirical formula. How to find out molecular formula? Let's do 63. In order to find out molecular formula, from an empirical formula, you have to know or you have to find out another data that is called molar mass. So you may be thinking, if I don't know the molecular formula, how do you find out the molar mass? Because I have discussed in other videos before, the molecular or molar mass is calculated based on the molecular formula. But here we are trying to find out molecular formula, and I'm saying that you need to have the molar mass. Actually, you can find out the molar mass experimentally without knowing the molecular formula. That's a separate topic. It is a very standard chemistry technique or experimental condition or experimental methods by which molar mass can be found out without knowing the molecular formula. Okay. So what you have to find out is something called, as I said, if this is the empirical formula, this is C2H5O2. So if you know the empirical formula, you cannot find out the molecular formula for sure, but you can guess. Okay? So it could be same if the common factor is 1, if common factor is 2, this one will be C4H10 O4. If it is common factor is 3, so this one will be C6H15 and O6. So it means you have to find out these common factor, whether it is 1, whether it is 2 or 3 or 4 and on and on. And this one is found out by something called, represented by n. The n is this factor, 1, 2 or 3. How could you find out? It is called, it is a ratio of what is called actual molar mass, which is given, it is 183.2, and then divide by the empirical formula molar mass or empirical formula mass. Find out the mass of based on the empirical formula, that is called empirical formula mass. So what do you do? Based on the empirical formula, you find out the mass. So 2 carbon, 12 into 2, 5 hydrogen, 1 into 5, because the atomic mass of hydrogen is 1, oxygen 16 into 2. So find out how much it is. This one will be approximately 424 plus 529 plus 32. It will be 61. So empirical formula mass is 61. If you take this one, it will be, the n will be close to 3. So this is the common factor is 3. So the molecular formula will be C6H15O6B. So just to wrap it up, empirical formula you can find out from relative composition of the elements present in a compound, and then you need another piece of information, the actual molar mass. Without finding out the molecular formula, actually that's what you are going to solve for it. And then you can find out the n, which is the ratio of actual molar mass over empirical formula mass, and whatever the numbers you find, multiply the number of atoms by the same factor, you find out the molecular formula. I hope it is clear. Okay.